Today we are continuing to look at the solubility chart as well as its applications. We're doing this so that we'll be able to predict when precipitates form in double replacement reactions, and our success criteria is being able to predict the solubility of an ionic compound. So how do we actually go about doing this? Well, we need to know which ionic compound we're considering first. So for example, if I have barium hydroxide, BaOH2, what I need to do is I need to find one of the two ions involved in that compound. Either the barium, Ba2+, or the hydroxide, OH-. Where I'm going to look is I'm going to look at this top ion chart. So on this row, I need to find either the Ba2+ or the OH-. I won't see the barium, but I do see the hydroxide over here on the right-hand side. Looking down then, I see that barium 2+ is in the high solubility level. That means that barium hydroxide is highly soluble in water and will be able to dissolve. What about a different compound? Let's look for silver sulfide. I'm going to do the same thing here. Even though silver sulfide is Ag2S, remember that the ions are not stuck together for the metal. Okay, there are two silvers, so we're just going to look for Ag+ individually, and then we need to also look for S2-. So looking across the top here, I don't see Ag+, but I do see S2-. This time, I do not see Ag+ as one of the exceptions. And then I see that most of the ionic compounds made from sulfide ions are low solubility. So since I didn't see silver as a high solubility exception, that means that silver sulfide has low solubility. So of these two compounds, barium hydroxide is able to dissolve in water and become an aqueous solution, where silver sulfide is not able to dissolve in water and it will remain solid if you place it in water. An application of this is what we call a precipitation test. We can predict what ions are in an unknown solution based off of other solutions that form a precipitate with them. For example, a common precipitation test is the addition of silver nitrate. Now, silver nitrate can test for several different things, but one of the most common ones it tests for is the presence of chloride ions. Why does this work? Well, if we look at our solubility chart, we can see that silver nitrate is going to form a precipitate with the chloride ion. The chloride ion is right here. One of its low solubility exceptions is the silver ion. We're also using silver nitrate because we know in silver nitrate that it has to be the silver reacting, not the nitrate, because the silver is able to form precipitates, but the nitrate isn't. Nitrate is always soluble in water. In fact, we sometimes call it a spectator ion because it just watches chemical reactions. It never participates in them. So silver nitrate doesn't narrow it down a huge amount because silver does react with a lot of different things to form precipitates, but it starts to give us an idea of what might be present here, and we can use other precipitation tests or other diagnostic tests entirely to try and narrow down exactly what is in this unknown solution.